All right. Should be live. It's been a while, right? So yeah, I'm going to be looking at something that's been on the back burner for a long time for Asahi. So back in I think it was like February or something like that. I think I submitted the first version of this. We have the CPU frequency scaling driver, and the CPU frequency scaling hardware on these machines is super simple. The driver has required some yak shaving. So what happened is that well, I can kind of show you what's going on. One sec. Let me get my text editor app up. Get the documents up. Just give me 1 second, and I'll switch to the screen. Okay, let's go with that. I just need to make sure I don't spill my water here. Drivers, CPU frequency, sock. Okay. So the we're talking about the CPU frequency scaling on these socks, and the hardware is super simple. You just write one register, and that's it. That's all there is to it. But that register, just takes the index of the performance state you want to go to. The problem is not the driver part. It's the design when it comes to Linux. Because the problem is that Linux only so the hardware has one of these registers per one of these blocks actually per CPU cluster. So on the M1 there would be 2 of them. On the M1 Pro and Max there would be 3 of them. M1 Ultra would be 6 of them. And so the hardware is logically independent for every single CPU cluster. And so the issue here is how do we represent this in the device tree host? So here is the example from the M1. And so we have the frequency tables that tell it just what the frequencies are for every performance state. That's easy. That's not a problem. And then the issue is, okay, how do you represent the actual hardware? So the original approach that I don't have the device trees handy for that anymore, represented each instance of each cluster as a clock controller, and then used a thing called CPUfreq DT, which is built into Linux. And what that does is it lets you associate every CPU with a clock controller, and then just sort of handles everything. The problem with that is that this hardware isn't really a clock controller. It's higher level than that, and so representing it as a clock controller is a bit clunky. And it also means that you're going through the entire clock framework, which is overkill. And then you end up converting between clock frequencies and performance states. And so that also means that you can't use like fast switching, because the actual CPU frequency switching on these things is very fast and very efficient, and so you can do it at a very finer grained level, which means that you can switch to full performance and run something really quickly and then drop back, and it's a lot more efficient if you do it that way. And that doesn't really work with the clock controller model, because it goes to the entire clock framework, and that has like locking and things like that. So there's the underlying CPU frequency control in Linux has a function that can do atomic clock frequency changes. That doesn't work with CPUfreq DT, and that kind of sucks. And yeah, modeling this as a clock controller is just wrong. So The second take was using it, like modeling it directly as a CPU frequency driver. And the problem with that is that in Linux, you can only have one CPU frequency instance globally for the entire system. So, no, Apple P-states are not unique. I think Intel and other things do it like that too. And also Qualcomm also does it that way. So what I did here, the current state of things, is that there is a single device that effectively represents both clusters with different register ranges. And this is actually how Qualcomm does it. And then you need some kind of binding to go from the CPUs to the hardware. The problem is that the device tree is supposed to represent the way the hardware works. This is not how the hardware works. There isn't a single CPU frequency block. They are independent. And we actually ran into this problem on the M1 Max and the M1 Ultra. Sorry, because you ended up with two copies of this block, the way the device tree was set up, and so that doesn't actually work. And so we would need to work around that and have it, done separately for that one. It's just wrong. Like this is leaking Linux implementation details into the device tree, which is not what this device tree is supposed to represent. The device tree is supposed to just represent the hardware, and then Linux is just, just deals with it, right? So, I was talking with Rob, the device tree guy, on IRC the other day, and he told me about a couple things I didn't know about. Apparently, there is a performance domain binding that can take the place of this Apple frequency domain thing that I came up with. So that's good because we don't need to add a custom binding for that. But then I found out that MediaTek uses it. But then what Rob said is that, no, actually, what you want to do is Linux can only have a single device instance. And the way you do that with the driver is that you actually register the driver like as a platform call. So it gets, your like init call gets run when the driver loads. And then what that's supposed to do is check to see whether this is an Apple device. And that is checking if machine is compatible. So there's like a global, is this an Apple Silicon machine check? And if it is, then it would actually look for the individual cluster nodes, and you would have individual nodes for every cluster. And if it finds them with the right compatibles and it supports them, then it would interpret that data. So the device tree represents the clusters separately, but Linux implemented on one driver, and that's how you fix that sort of disconnect between the Linux side and the on the device tree side. I didn't know that this approach is like recommended and what you're supposed to do, though in retrospect, CPUfreq DT basically does that, kind of, since it goes through the CPUs and then looks for clock controllers and stuff, and it actually has a platform call like that to initialize. So yeah, I didn't know that this was the way. But if Rob says this is the way, I agree that this makes a lot more sense than what we do now. So this is going to be take 3 of the clock controller rewrite. And I'm going to be testing this on the M1 Ultra Mac Studio because that's also a good test case. Yes, the thing is, like, that's the driver only, right? But the idea is that this, the device tree for the M1 Ultra is just going to have, like, it fits into our model. Let me show you. You have T6000X DieX, right? This is actually broken right now because of that. So what we actually need to do is grab, so we have a die 0 and then a die X. And the problem is that then we don't have the CPUfreq for the die X. And then there's a common one that has the CPUs in it. And then I think what we were doing here, what was it? T6000 DTSI. So let's look at the M1 Pro. No. Where is the CPUfreq ranges set up right now? I think T6001. Yeah. So T6001 has the 3 clusters. And then T6002 has the 6 clusters, and so this is weird because this doesn't actually work because we are in die 0, and then the way this works is that we include die 0 and these are translated. So this translates the MMIO for, like, it basically it maps the MMIO ranges that are in that die. And because these ranges are in the other die, that actually doesn't work. So the hack would be to just add like the second die translation here. But again, this is just hacking around. This doesn't represent the hardware, right? So this part is fine. It's just that this part is dumb, right? This CPUfreq hardware shouldn't be in die 0. It should be in die X. And it shouldn't be respecified here in... Wouldn't this also be needed in Intel's performance cores? Yeah, but like the Intel stuff doesn't use device tree, so it doesn't have anything to do with how we do it here. They would use ACPI, right? So this is specific about like embedded SOC devices using device trees, which basically means ARM. So yes. So what I'm going to do is we're going to go ahead and write the device tree description first, and then try to fix the driver so it actually works. So this goes away in die 0 and goes into die X, and it is going to be the beginning. And then we have die node, so we need to have the same die node thing. Let's just go to CPUfreq. And then the compatible for this would be T6000 cluster CPUfreq, which is backwards compatible with the M1. And we'll give it a default compatible like that. And so it's not frequency domain sales because Rob mentioned the new binding. But first, let's get the registers in there. So because there are 3 clusters, we need actually 3 copies of this. So it would be CPUfreq. And then we have isn't this wrong? Doesn't this only have... I think we're missing P cores here. Wait. No, it is right. Sorry, 4 cores times... Yeah, that's right. So we're calling this CPUfreq E. And then we'll have CPUfreq P0 and CPUfreq P1. And so these get these register definitions, and so that is 0, 1, and 2. And because this is in die X, that means that this is going to get translated into the right offset when we instantiate it twice for the M1 Ultra. So this is going to give us our 6 instances for the M1 Ultra, which is exactly what we want. So this makes sense. This represents the hardware. We have 3 clusters in every die, which means 3 clusters in the M1 Pro and the M1 Max, and 3 plus 3 clusters in the M1 Ultra. This makes sense. Now the CPU mapping. Those are set up separately. They are... The base ones are in common, and then the Ultra adds another set. So here we have these, and so instead of CPUfreq domain, we need to use that performance, whatever thing it was. Performance domain binding. So let's look for that. Yeah, so only MediaTek uses this so far. And we need to call it performance domain cells. And then it's performance domains. This is the thing, right? It's like the sort of right way of doing things keeps changing. Oh, look. Maintainer is another Hector. That's cute. So yeah, this is going to be very similar to what we want. We're going to have performance domain cells in there, and that replaces the frequency domain cells. Actually, we don't even because these are actually now a single cluster. It's performance domain cell 0. So MediaTek is halfway, right? This is not the right way to do this. They are doing the same thing. This kind of makes sense in MediaTek's case because the register sets are at least adjacent, but it's still a bit weird. So they are using a single node like I had before, but they're using the standard binding. We're going to use a single node. Sorry, we're going to use multiple nodes, and then we're going to use the standard binding. But because it's now 1-to-1, one CPU will only belong to one. Like once, like each CPUfreq node only represents one cluster. Then you don't actually need any cells because the cell is like the index. So we have performance domain cell 0 because there's nothing to specify. It's just that this is a performance domain. And then it means that here in the CPU side, you say performance domains, and you just say it's going to be CPUfreq E. But because these are, this is P0, I need to call this performance domains. But because these are the dies, we need to do something about that. Make sure that we are. Should just copy and paste this whole thing. I need to make sure that the naming there is right. So actually, let me fix that first. So the die node here, I forgot how this works. The die node here is done. I'm not sure how that's done. The include for that multi-die CPP. It just concats the thing with the die, and then it stringifies for the label. So let's look at. Hey, this is so for T6002 we say die. Okay, so it's die 0 has no suffix and die 1 has a die 1 suffix. That is good because it means the die 0 will have no suffix, so that works fine for T6000 and 6001. And so this is fine. CPUfreq E, P0, and then we'll just keep doing that for P1. Sorry, this is still P0. That one is P1. Because these are global, right? So this is just has to have the dice hard coded in, which is fine. Because I guess we could try to do something with the CPU IDs here, but I don't think it's worth doing that. So this one will be die 1. Yeah, they're not templated, so P0 die 1. And that should be it. That should be all it takes for that. So now we can just delete this because it's also not necessary. And T6000 doesn't have anything. And then as long as this stuff, where is it? Common. As long as we can make these OPP tables work, which is basically the same thing we already have, that should be fine. So we're going to test with these device trees on T6000X. And if it works, I'll just backport it to M2 and M1, and that'll be that. So first, let's see if that actually builds. That did not build. I bet it's another semicolon. I always forget semicolons. Oh, yeah, I messed up that. Okay, yeah, that builds. That's good. I also need to fix the binding, of course. So now, for the actual thing, Apple sock CPUfreq. Um, I don't know if I should rename this. I think the driver name is fine as Apple sock CPUfreq. It's just the compatibles should be Wait, why is that not even? That's weird. Why is that not called sock CPU? That's a bug. That doesn't make any sense. Um, so So all this stuff is fine. And now the trick is that this cannot be a match here in the driver. So what we actually need to do is similar to what CPUfreq DT does, which is here. It declares a platform driver, does a probe. I think if we don't match on anything, it will just call probe. And then we check that. Or this gets instantiated somewhere else. I forget. Hold on, let me just search the CPU because I think it was somewhere else that gets called. Is there something in DT? I think, or not? There's a platform CPUfreq DT. The plat dev I think is the one that has that. Yeah. Yeah. So this sets up a core init call and then calls plat dev init. And that actually goes through, checks to see if this is not one of the like block listed platforms, which includes the Apple ones because those don't use this driver. And then instantiates that driver. So that's not exactly what we want to do, but it's similar. So what I think I want to do is declare a module alias that will match the compatibles so that the module gets auto-loaded when this hardware appears, even if it isn't actually probed. And then what Rob said is, yeah, an init call, but it wouldn't. I don't know if core init call works on modules though. Yeah, it's module init. I basically want this module init. So maybe about device init call. Yeah, CPUfreq is using this kind of stuff. Yeah, and because for Intel, it's the same. It's effectively the same thing as for Intel because the device tree handling is going to happen in the init call. So, so we're kind of mixing concepts here. So we do want the OF match because that's going to be used later. And but there wouldn't be an actual platform driver in this case because it doesn't match anything, I think. So what? Unless we just instantiate it from the init call like the CPUfreq DT plat dev does. Yeah, that probably makes sense. And then we have that driver look for the other nodes. I think something like that makes sense, yeah. Because you still need a device that, like, exists. So we're going to do something similar to this. We do apple socks plat dev init, hit the device node, and then in this case, it's going to be very simple. If not, where is that? If machine is compatible, dev. And yeah, so we want to use module init in this case, I think. It's really the same as device init call, though. Why would this driver ever reload if that compatible was all true? Because someone did mod probe apple sock CPUfreq. Current state is always sees all CPUs as a group. No, it sees all CPU cores in each cluster as a group and applies CPUfreq. But that's because the hardware works that way. You can't set the frequency independently for a CPU. You can only set them for every cluster. So this is the way the end result is not going to change. We are just changing the way it is modeled in the device tree. So nothing's going to change for end users. It's just that what we have now is not upstreamable, and hopefully this will be. But also just because this could be built in, right? So we'll call it module init. Let's call it module init. Apple sock CPUfreq module init. And then we just check the compatible. And if it's compatible, then just platform device register data. We're going to call that Apple sock CPUfreq. And there's no data in this case, I think. What is data used for here? Oh, it's the match. Yeah, we don't have any match data worth talking about here. Yeah, I'm running out of columns here. Okay, so that should take care of registering the platform driver. And then we set the module platform driver and then CPUfreq DT. So the alias doesn't actually matter in terms of CPUfreq DT in this case. What I actually want to have is the alias be the these compatibles, but specified explicitly because so I don't know if I can just set the table. I don't know if I can set the module like table device table. Yeah, I think so. I think I can just set, yes, I can just do that. So if I just do module device table and explicitly set this device table, that should oh no, it's already there. It's already set as, sorry, I'm dumb. We already have the module device table, so that's fine. Then we don't need that module alias anymore, because as long as any of those devices match, it will load the module, that'll create the platform device, and of course, that's yeah, so the other thing is module platform driver, I think, is going to set an init call for us. And that's probably going to conflict with module init. So let's see what module platform driver does. Let's see if we can do something to create that. So that does a module driver. And that does sets an init call and sets a module in it. Yeah. So we probably want to do something else, unless there's a hook for this in the platform driver. Any system on chip that can have multiple frequencies is assumed to be managing that on the hardware and the driver only also have only one. I'm not sure what you mean. You mean like multiple frequencies for a single CPU, like multiple clocks? So there's a platform driver register, and what does that do? Can we hook that somewhere? That does a this module. Okay, so we can also just call it manually, which is fine. Where's the code for that though? I just want to see if there's any hooks we can use for that. Feels like there's a model in driver management in Linux that cannot reflect all real life scenarios. No, it's just that the Linux expects a single driver instance to manage all CPUs in the system. It doesn't mean those CPUs can't have different frequencies. They can. It's just that in Linux's idea of what hardware exists, there can only be one piece of hardware that manages all the CPUs in the system. And that's not how real hardware works. So it's just a software model thing. It doesn't matter that it still manages the CPUs individually in as many groups as it wants. It's just that they are not separate device instances in the Linux driver model. So that's sort of the mismatch there. It can still represent anything in real life hardware. It's just it maps weirdly. So where is that? Platform or something? Let's find something nut. Where's the core for that? Actually, let's look for the underscores. There we go, base platform. Okay, so it just says that driver register. And so can we... What's a struct platform driver? I just want to know if there's a hook we can put there or... probe, remove, shut down, suspend, resume, device driver. No. So yeah, we'll just do it manually. We'll just do platform driver register, and it'll be the same as any of these. Yeah, we basically need to specify these manually, which is fine. So just do a bit of copy paste here. So we have the init. So that return is fine, but we need to register the driver first. So int ret equals platform driver register the Apple sock CPUfreq plat driver. You get rid of that. If ret is in 0, return ret. Otherwise, we do with the actual device register data. And that will be the module init, and then we need the exit. Sock CPUfreq module exit. Let's just call it init and exit. It's a bit easier. And so this doesn't actually need to do anything. We can just do platform driver and register, I'm pretty sure. I should fix the tab there. Is there some graphical representations I could read some more? Yeah, and not really. That's the thing with Linux, right? Is like everything is always changing, and so a lot of it is like some important core stuff is documented, but so much just isn't, and then you just have to dig around or ask people. It's just kind of how it is. I saw db frequency init and exit. Yeah, that should work. We got that, and then the standard probe and remove. And so in this case, the match table wouldn't be in the platform driver. It would be the same as CPUfreq DT, so that's fine. And we don't need the module alias for that because that's not useful anymore because we just have the device table. And so now I want to actually move the probe and remove calls below this because they're going to have to use that. I might put this at the bottom so it's more obvious. So now we have the probe call, and here is the tricky part. Before we already had all the, we knew it was matched already, and we had all the info we needed. Now we don't. So this has to actually look for the CPU frequency nodes, and the question is, what's the best way of doing that? We could enumerate CPUs and then follow the performance domain. Let's see what that MediaTek one was doing. Let's open that. Performance domain. So this does CPU resources init. And that gets called from hardware CPU init. You might just be able to kind of do it the same way, because now we already have a function here that gets all the CPU devices, adds the OPP tables, and does a find cluster, and the find cluster is checking this, so we need to do the same thing with the, where is that? Performance domain and performance domain cells. And there are no arguments in this case, because it's going to be a single one. There's no index. So what we actually want is the p handle here. So this is different. Does Asahi Linux have a Discord server? No, it doesn't. So this one. Yeah, why is that in a weird? Come on, I thought there were docs for this. Kernel org. Device tree kernel API. Google is not very good at finding these things. Yeah, so out args. It's not args, it's args p handle, I think is what that's called. Olive p handle args. And of course that structure is not documented here. Oh, it's just an NP, okay. That's good. Then we just get the device node directly. It does the p handle for us. Oh, it does get args NP, sorry. So we already have that. And it's not reg names anymore. We're just going to get the reg because there's going to be a single one. So it'd be not platform get resource. OF, IOMAP, MP, red. That's just for the index. So it would just be 0. We're not going to worry about that. We already have the reg base. This is going to be pretty easy, actually. Cluster %d. Yeah, we don't need that. We don't need the index. There's no arguments anymore. This is the first reg. And then it goes and looks for all the CPUs with the same. Oh, but there's an OFPerf domain. Oh, this is a thing already. Sorry, I just missed that. There's already scaffolding for this. Nice. Interesting. It's inline. Okay. So it does a parse perf domain. Oh, nice. Okay, so this is all done already. And then this. Oh, cool. Okay, so that's all easy. Let's just take that then. The question is, do we get any of the p handles out of this? Yeah, so it does get the policy CPU performance domains. Yeah, that works. Policy CPUs. Yeah. Let's go with this ret. And that returns an index apparently, but what is the index? Because what I actually want is the NP of the. Returns the target index, which is what? Parse perf domain. Oh, that's not good. It assumes it's the. Okay, that doesn't work. Ha ha ha. Nice try, but that's not what we want. Whoever wrote this was using the crappy single device model. So because then this is checking to see if the index is. Yeah, that doesn't work. Okay, too bad. We can work out whether this should be shaved. Check should be shaved or not during review. But for now, we're just going to do the p handle parsing manually. Really, what this should do is it needs to return the entire p handle reference and do a full comparison of the entire arg structure, not just an index, and then it should be returning the entire p handle reference. That's what this should be doing. Maybe we do want to change that, although then yeah, okay, let's refactor. Let me git log this, see what we have. Blame. Let's go with perf. Yeah, this was actually just last year, so yeah, it's good to know because this didn't exist when we first started working on this. Yeah, let's refactor then. Let's be nice. So what we have here, perf, or perf domain, cell name, list name. That's fine. But then what we want is a OFP handle args. Args, and we just return that. Is that struct? Yeah. And so then we just pass that directly, and we are returning 0 in this case, because it's all good. Could return arg 0, but... And so now the same thing here. Get sharing CPU. You're going to have a out parameter for that. Get sharing CPU mask. Why are these inline anyway? I'm not sure if that makes a lot of sense, but sure. Parse perf domain. We give it args. And is there a comparison tool for that? Do we have a OFP handle args comparison operator? print p handle args. Get the feeling it's not a thing. No, I think we just need to compare it manually. If so, we're gonna do parse perf domain. Let's say args2. args2. If args dot np equals args2.np and not memcomp args2 args size of args 0 times args dot, what is that called, args count. That fits. Yeah, that makes sense. So if we have the same nodes and the same arguments as far as arguments exist, memcomp 0 is defined to return 0, right? I sure hope so. Yeah, okay. Okay, that makes sense. And so then the only, thankfully, there's only one user of this. Policy CPUs, args. We give it there, args. And then it's not index 0. It wouldn't be indexed if you use ret. If ret is less than 0, return ret. And then index is just args 0. And that's it. And so no more index anywhere here. Well, sure. Or we can just set it. Args 0. That's what we want. And now I can actually use this API. Because it's going to give us actual nodes. So I can just redo that. And then we have policy CPUs. And we get some args back. Ret 0, return ret. And we can drop all of that now because we already have the sharing. We just need to IO map it. Reg base is args np0. If not, fits an error, return a pointer error. And then we don't need that anymore. Does that header file do the... There's that. Parse perf domain. Yeah, it does the put and everything, so that's fine. So we don't need to do any of that. So it's just OF IO map, args np. The only thing is the args. Is this actually going to... I don't think this is going to get the node. Oh, caller is responsible to call OF node put on the returned out args np pointer. Well, that's a leak, isn't it? Yeah. Okay. So, that needs to get an OF node put, and that means this was already buggy before, because it wasn't calling that. And this needs to do OF node put on those. args2.np. Oh, and this would be args. Yeah, that's a pointer, so args like that. And that can just be the first one. Hopefully the arguments count as the same, but it should be because we are using the same cell name. Actually, yeah, let's make sure the counts are the same. args2, args count, and all that. Then we call O with node put, and that means that this one, the MediaTek one, also needs to do that. So, O with node put, we get the arguments, we do the remap, let's make this some cleanup code, put node, xmp, return ret, and let's make sure that the error paths are handled properly. Yeah, so if this returns that, yeah, we don't have to do put. If that returns, I don't have to do put. These are continuous, there's no returns. Yeah, that looks good. And the MediaTek one does a put immediately because we only get the index, so we don't care about the NP. That's fine. And so in the Apple one, we don't need that anymore because we already have all that. So basically just get the reg base. And so then this initializes all the policies, and that should already get all the sharing things. So now the trick is that we need to get the compatibles for that. Apple sock CPUfreq info. Where are we storing that? It's in the priv. That has the reg base. That is for CPUs, so that makes sense. And then yeah, we do get match data. That's not what we want in this case. Get the reg base, gets put into priv. Let's just put it there into an info, and then we can just say that goes in here. Info and info. Also, are we ever doing the unmaps properly on here? Yeah, I do an unmap, so that's fine. And we don't really care about the SOC device nodes at that point, because if they go away, nothing really changes, nothing references those. So now I just need to get the info thing. Pointer. Should be const, actually. Because it's a const pointer. And that is a const pointer, yes. So then we just return that. From here, from the find cluster, ** info. So before we do the IO map, let's get the info out, and that means we need to do a OF match against a node. Yeah, there's an OF match node. I think that's what we want. Yeah. So if we get the args, so if this is an error, then we want to do ret equals that and go to put node. Actually, we can just do it like that. And just say ret equals 0. You have CPU? No, we don't use that anymore. We don't have an index anymore either. It's just, we even have a name? No, we don't have a name anymore. All this goes away. And CPMP also goes away. It's just the args at this point. Args match node. And so the match for that, which I guess we're going to move to the top just to avoid having to have that take forever. Let's put this, I guess, at the very top, because why not? Apple sock CPUfreq match np args.np. And then the way we look at that match stuff is... Oh, it doesn't even... Okay, that's not good. It doesn't even check if it's valid. Yeah, if not match, well, as we get the match data. So... call that eno-dev, and then go to put node. And then we can just say info equals match data. Yeah, just put it here, I guess. How does that work? Like, OF match node returns a pointer to what? To an OF device? Oh, okay. It's literally a pointer into the array. Yeah, sure. That's why. That's fine. Yeah, that makes sense. And so now, yeah, I think that's all we need. We're matching the arguments. We check that we know the cluster against the NP. And actually, we can just free that at this point, and then we don't have to worry about it here. Yeah, actually, we can just do that here, and then we don't have to worry about this put node stuff. If not match, return eno-dev, and then just return pointer error. Return 0. I think it'll do it. Makes it a bit easier. And yeah, this might just work. So we have we get the CPU device, all that. Then we find the cluster, which is giving us the info pointer, and that is const. Do we have this const? Yes. Find cluster gets the info, and then yeah, we just set it there. I think that's it. That's really all that has to happen. And then this just probe just registers the CPU frequency driver. Which gives it the platform device. Do we even need that anymore? We might not, because I don't think we need the platform device for anything at this point. Not the policy. That's the frequency table stuff. The platform device. We might not need that anymore. Yeah, because the policy one is that one, but yeah, we don't use that anymore. Yeah, and that means this can even be const at that point. I think that can just be const. Does this do any changes? No, it doesn't make it const. Okay, so we probably can't make it const. We definitely don't need to mutate it there, though. And then we just register the driver. Does it even need to be a platform device at that point? Because it's just a CPUfreq driver at that point. Hold on, let me just look at what go in there. Sys. Yeah, so we have Apple sock CPUfreq here. There is a so that is actually bound to the hardware, of course. But the question is, yeah, this is just a system driver, so there's no need for a platform device. We can just ditch that. I think we can just drop all that. Yeah, we don't need the platform device for anything. This is just an extra indirection step that doesn't make any sense. So in it, we just check if it's Apple. If it is, we register the CPUfreq driver. That might fail if the policies are wrong. That's fine. If yeah, we just return that. That's it. And then we can drop all that. That's module init, and then this is the unregister. That goes away. All that stuff goes away. And we are left with the CPUfreq driver only. Hey, simpler. No platform device. Are there any PDEVs? We have a PDEV there, which you don't use anymore. Yep. And there is no platform device anymore, so this can go away. Yeah. Does that sock have a controller that needs bus? I don't know what you mean. Okay, let's see if that works. Obviously a bunch of errors. I think I forgot an and on there. Yeah. And args2 is not. Let's call it something other than args2. So other args. CPU args even. Actually, you know what? We have pCPU here. But pargs. And then you just have args. Args equals pargs and pargs equals pargs or count. And so pargs is actually this one. count equals args arg count, p args args, args args, args arg 0, args, do it like that. With node put args np. Let's go with p args. Better p args np. Yes, that needs to be a pointer. I think that's working. Almost. And then the Apple sock one, also forgot an ampersand there. Apple sock CPUfreq. And args. Match undeclared, yes. OF match. Does it match or OF device ID or something? OF match. OF device ID, that's what it is. Conflicting types for Apple sock CPUfreq init is that. Did I forward declare that for some reason? Oh wait, no, there's more than one. I guess that's the CPUfreq. Okay, let's actually call these module init. Okay, 336. Unused variable ret. Yep. And then I also want to compile this MediaTek thing because I want to make sure I didn't break it. MediaTek CPUfreq. I think it's that one. Arch MediaTek. This is going to be I think it's that one. Yeah. We don't have regulars? I thought we had regulars. I'm going to need that for the PCI stuff anyway. Fixed voltage regulator support, yes. There we go. So now this one, MediaTek socks. Let's compile that, see how much chunk we have just added to our kernel. And make sure it works. Well, I can't test the MediaTek thing, but if it compiles, it should work. This might take a while now if too many headers change. No, it's going to the MediaTek stuff. It's mostly just building MediaTek-related devices. I can live with that. To make sure to turn that off later, so... That's a lot of randomness. Yeah. Okay, built MediaTek CPUfreq, so that... No, it didn't. The hardware one didn't. Yeah, I forgot the ampersand there too, so that's good. Fix that. And is it going to work? Run guest kernel. I think that should work. Yeah, let's give it some firmware. 20 CPUs. Oh, that didn't... Oh, sock dies. Yeah, something was... that. We were missing some mini patches for this, I think? Or what was it? Something is not synced here. Yes, I modified the DT, but clearly I am missing some. So this was using aliases. So there was a mini patch, which I guess I haven't merged. Or is it just not built? Oh, I think it just didn't compile it. I should have mini updated. It's just that I didn't build it, I think. That looks good. Okay, that exploded, or is that just... That looks different. That's unrelated, I think. Uh, 9:10:39. Sorry. It's looking for CPUs and not finding it. Ah, it's this FIQ index. Okay, so probably something else broke the CPUs there. And also clearly that's the wrong root device because it's not working. What was the root device? I was testing. Wasn't it this one? Oh wait, no. I reinstalled Asahi here for the I reinstalled Asahi here for the Academy demo when I recorded that. So I probably ended up with another device number. 1, 2, 3. Wait, why would it be 5? 1, 2, 3. It should be 5 by default, but I probably added something. It might just be 6. No. I'll have to check that and probably just use an init manifest. But what actually happened here? Did we like lose CPUs or something? That's not right. CPU 16 for starters. Oh, maximum 16 clipping. Yeah, okay. Why did I end up with 16 cores? That would not be good. Where was that? Yeah, that's not gonna work. Let's give it way more. It's just gonna be one of those things where everything changes. Yeah, I think so. You're gonna have to wait a while. All right, I'll be right back while that compiles. Actually, yeah, I just realized I should be able to get more parallelism out of that. Maybe. Well, I guess I can turn off the MediaTek junk now. That I know it compiles. I think that turned off enough. Let me look at the log while I'm there. Do we have any CPUfreq stuff loading? I don't know. No, it doesn't look like it. Not sure if it didn't work or if it's just silent. It might just be silent. Kernel compiles. I need to switch to actually using the Mac Studio as the build machine pretty soon because, yeah, this is getting kind of crazy. Still on an ancient Intel. But, yeah, I think this driver is only 350 lines of code. It's very, very simple. Like, it says most of the, like, more than half of the driver is just scaffolding, and the actual driver part is like these two functions. That's the entire actual driver part. Dun, 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 dun. I've got Spotify in the background. Ah, there we go. I finished. That's good. Let's give that a shot. Yeah, that's not exploding anymore. Oh, I still have the rootfs wrong though. Let me get an initramfs on there. Initramfs. Yes, give it firmware. Don't know if it's up to date, but is it just still loading? Hello? Okay, it's just slow. Wait. Oh, that was. Oh wow, the NVMe exploded there. That's an NVMe error. I've seen that before, and I don't know. Let's reboot again. That's not good. Oh wait, maybe that's why it wasn't working in Linux, because like NVMe is dead. Maybe that's why I didn't find the partition. Let me do a hard power off here, but this is weird. The annoying thing is that we can't see the actual exception at the top because it just scrolls off the screen, which isn't great. I think all this goes out to serial by default, so if I set up all my serial stuff, I might get it. Yeah. Okay, why is NVMe dying now? What happens if I just if I do one of these? Is it going to at least reset the controller? No, it just fails in it, but it doesn't tell me the... Well, that's not good. Because also, this was just an install from the most recent, like Asahi as a few weeks ago, and I don't think we fixed anything in NVMe. Can I get a serial log out of this? Or what was that even? No, did we only build that in, I forget if Mini actually does the serial stuff, or only if we build it with that. Is it in utils? Printf? Yeah, just as IODEF console. There's an early UART base, but yeah, we do have UART in it. Okay, so we do actually check the UART. The early stuff is really just for early mode. So it should work. Okay, let me see if I can get a log. I need to plug that into the right thing. I forget which port it is. Mac Studio. Okay, it's the other one. Do I have my Glasgow stuff still set up? FPTS37 looks like it. Let's see if that works. Get a log out of this. Yeah, okay. At least we have a log. Huh. Okay, so it's a timeout. But that wasn't a very long timeout. It might just be a dumb timeout. I think this is just one of those things where we try to shut it down the bad way. Like we're timing out for whatever reason, probably because I did a hard shutdown and it doesn't like that. Yeah, I think it's just a timeout. Source. So I bet if I boot macOS and then boot Mini again, it'll work. It's not gonna say do a clean shutdown. It doesn't ANS boot. Yeah, didn't U-boot have the same issue with a timeout? NVMe timeout. This is set to 1 second. And I wouldn't be surprised if, I think yeah. And also because I think iBoot uses like a special mode where it boots it in like read-only mode or something and doesn't actually do replays. We don't know how that works or how to do it. It would be ideal to do that in Mini, but we don't know how to do it. So though there was that someone did publish the iBoot encryption keys for M1 at some point. So maybe that's worth looking at with a disassembler just to see if we can find, how to make the NVMe start up in read-only mode, because obviously that's ideal for bootloaders. Yeah, and so the thing is, when it times out like that, it goes to out disable control, and then it does control disable. And yeah, so that exacerbates the problem because we know that's going to break it. Because the clean shutdown, we know that breaks basically. So I think it's just a timeout. But we should also add this in here, because if we do that, even if this happens again, that would fix it. And it should be fine to do that. Where did I just go? Shutdown timeout is 5 seconds. Let's just make these constants. So let's say the regular timeout is 2 seconds. Actually, where is that used? They probably only want that timeout that long for the enable, to be honest. Yeah, the commands are fine with that. Enable timeout. So I think we can afford to wait up to 5 seconds if it's doing that. And so that is... Oh, that's... I broke that. Yeah, so enable, we'll use the enable timeout. Oh, hey, Avery. Thanks for having the chat with me on Twitter about the Matrix stuff. Yeah, there's, we had to disable the Matrix gateways because we had some spammers. Yeah, that should be fine. So let's go with that. That's interesting that nobody else hit this before. So we're gonna give it that. Enable timeout, shutdown timeout. Well, I was working on CPUfreq until I realized that the NVMe code in Mini is apparently buggy and doesn't calculate timeouts properly. So I need to reinstall now. But now the problem is that I kind of want this to have the chain loading thing, and I don't know what the chain load partition ID is. Well, it doesn't matter. I guess I'll reinstall later. I don't care about standalone boot. So let's just make this. And then I need a keyboard. So kill it. Go into options. Now I'm kind of surprised nobody else hit this yet. Well, I guess people normally do clean shut down their computers, but yeah. The good thing is that because Mini initializes NVMe in this common case, even if the U-boot timeout is too short right now, that should never actually happen because the Mini should have let the NVMe controller do a cleanup, an unclean startup. So I think we can afford to not worry about U-boot right now. We already had to increase the timeout on that for the M1 Max at one point for like more than 4 terabyte machines. C was it? That did not work. Sorry, I need the raw option. Ah. And what I'm going to do now is deliberately do an unclean shutdown. Just to make sure it actually works. Which need to make sure it's actually synced. I know it can take a few seconds because of this stupid Apple, like not syncing to NVMe thing. Maybe it's okay now. Okay, I pulled the plug, plugged it back in. Oh yeah, but this wouldn't initialize NVMe now. But that's fine because I can just try the chain loading mode. It should be equivalent. Yeah, so this isn't actually going to boot the right thing, but that's fine. As long as NVMe works, I'm good. Yeah, okay, chain load failed, but it did initialize. And then we get the proxy. That's fine. Okay. So hopefully that fixes it. I can't really test because I don't really know how to reproduce it. But yeah, hopefully that fixes it. So that means the partition is probably fine. It's probably just 5. There we go. And now, Trevor has suspect urine. Okay. That's an interesting one because the driver has nothing to do with us. But CPU freak. Wait. Okay, yeah, that's the firmware. That's fine. That looks good. Policies, yeah, that looks like 6 policies. All right. I think that worked. First try, other than the mini problem. Yeah, there's all 6 6 policies. That looks like it has all the right frequencies, and they are the right ones for the right CPUs. Max freak, curve freak. Yeah, I think that worked. That all looks fine. Yeah, no, it's working. What are the policies? I mean, are they software defined? Do you mean like the actual policies themselves? Like in this case, it's schedutil, right? The governor. But like what this means is independently controllable CPUfreq domains, I guess. So each policy is a cluster, and the number is the CPU ID of the first CPU in that cluster. And yeah, the actual, like, if you mean the actual policy, like what determines what frequencies get set, that's just Linux. Yeah, in this case, schedutil is a default, which is what you want for this kind of low latency CPUfreq device. Schedutil is pretty much the right choice. Yes, it has 6 clusters because it's an M1 Ultra, right? So each die has 1 E cluster and 2 P clusters. Yeah. Okay, then that's it. I just need to commit this and fix the other device trees, and that's that. So let's do that. That was nice and easy and simple to understand. Nothing weird going on. Oh yeah, I also need to update the binding, and I should run the device tree checker, so we can do that in a bit and do all the device trees at the same time. So CPUfreq E and CPUfreq P. Cluster CPUfreq. No reg names anymore. Did I get rid of that here? Yeah. Just the performance domain cells. That can go at the end, actually. 11E2 is the second cluster. So there's actually energy counters for the CPUs that the hardware manages, and that's also on my endless list of things. I know there's some initialization you have to do where you like read values from, I guess, fuses or fuse-like things and put them somewhere else, and then eventually you get like joules counted in some counters. But yeah, that's on the it's on the to-do list. Apple has this thing they call core level CLPC, core level performance control or something like that, or I think, or I forget what it stands for. They have a patent on this, um, which is like super fancy with PID loops and stuff with tasks, and I don't know how much of that really matters. But we probably would want to have some energy model stuff, yeah. So that's something to look at in the future. Okay, that looks fine. E and P, and then the M2. Performance domains. P, 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 and E. Yeah, Chatmate was looking at that, yeah. We were both kind of looking at it at one point. Also, we need to figure out these numbers. These are kind of a lie right now for the M2. I just copy them from the M1, but I don't think they're... I mean, you can't really come up with an accurate figure for this anyway, but ideally this would be remeasured. Oh, is there actually like a branch? I didn't know that. Hold on. Didn't realize that. Energy or scale. Oh, okay. So there was actually... I didn't realize that was actually... Oh, but okay. So this is just putting in the powers and not actually using the counters. Oh, okay. So that, yeah, sure. Um. Okay, yeah. So this is like statically measured and then adding the microwatts. We might want to add that then, yeah. Now that we have that. I don't know if we want to just throw it in for the next version, even if we don't have it for the M2. Because why not? I might just merge that. It's not gonna like horribly break anything, so that's why we're on the bleeding edge, right? So that's that. I think those are fine, and then we just go here and the same story. Yeah. So this was wrong all along. Like the compatible was not matching right. So this was falling back to the default, which is not correct. Still worked, but cluster CPUfreq, cluster CPUfreq. Did I do that right for T8103? Yes. And then that has that one. Make sure that it is yes. No clusters. And we have performance domain cells. Fix the node name. I think that's it. Okay, this is build. I also need to fix that. Of course, I messed something up. Oh, yeah. Yep, it gets the device tree. So let's fix the binding. Documentation, device tree bindings. CPUfreq. Apple sock CPUfreq. So it's not called that anymore. Yeah, this is all fine. Also, this needs to be updated for M2 also, so you might as well do that now. And this is wrong, because the way this is done on T6000 is actually... it's either... We need a one-off here. Yeah. Properties compatible, one-off items. I mean, we can push the values on, even if they're not 100% validated, because it's not gonna like horribly break anyone, and might as well start testing it. I think it makes sense for the binding, and then reg is just one. Yeah, I think we just want that reg. I think I just want max items one there, yeah. And no reg names in this case. Const 0. And this would be in performance. Domain sales. Required. Yeah, that's fine. And so we would call this performance domains. OPPs are fine, and then we would have two of these. And that's cluster. And there's also a reason why I'm sending this to a different compatible, because I think the BSD folks implemented this already, and they're going to hate me if we change the device trees. So having different compatibles means we can actually just have the old CPUfreq nodes also, and the old Apple freak domain thing. And it'll be compatible with the old kernels and the new kernels, hopefully. So it's good to change the compatible in this case. I think that'll work. And now the forever device tree checker things. Was there a way of binding check? There was a way of specifying which one, but I forgot which one it was. Check. Yeah, okay, let's just do everything again. This always takes forever. Oh, did I mess up? It is P. Oh, yeah, here. Sorry, thanks. And I'll be right back. Just gonna go to the toilet. And when I come back, while that checks, I'm also going to do the git commits. Ooh, that's not good. Items. Oh, one of, yeah, that. Yeah, it's not complaining now. That's good. Indentation. Expected 10, but found 8. Oh, yeah, because that's supposed to be like that, I guess. Additional property certified. Oh, yeah. Apple cluster. CPUfreq. Oh, and this is supposed to be cluster. Ah. Okay, be right back while that checks. Okay, I'm back. Let's do a bit of commits. So, diff should be pretty simple. Yeah. So first, the fix-ups to the MediaTek and CPUfreq stuff, which has to be one commit because it's refactoring. It looks like it's just CPUfreq. Yeah, that's CPU. Am I include? Wait, where? Yeah, CPUfreq. Yep, I think that looks good. Okay, next up. Get status. Well, I mean, this is the fix-up, so... it's all gonna get squashed. Anyway, so... I think I'm just gonna squash it with everything. So I'm just gonna have it as separate commits for now, and then when we actually send this for upstreaming, I'll just rebase again and squash things. Hmm? Oh, right, because that's... Oh, the get move went in there. That was wrong. Damn it. Yeah, because I did a get move and that was staged. Um... I will fix this by doing this. Will that follow properly? Yeah. Uh... It's gonna get squashed anyway, but... And I will make these separate. Oh, I also need to add that. Do that later. Am I planning on looking at something else after this? I was wondering if I should go back to PCI Express power management. The Wi-Fi suspend stuff should be relatively simple to implement, I think. And then maybe see if I can hook it up to the PCIe stuff. I'm not sure. But maybe, yeah. Maybe that's a good idea. I think the other thing is that I have to do some kernel wrangling, so I do want to get some stuff merged at least. So let's let me get these commits done. Also see how this is doing. Looks fine. It's not me. I don't have any CPUfreq yet. No, it hasn't even gotten there. So let's put these in first. I think that's everything. Oh yeah, I need to do this one. I'll commit this one too. Ah. That makes sense, and that's pretty simple. So I don't know the pull-up. I never figured out. We don't support pull-ups yet. I think pull-up makes sense, but because we haven't tested that and don't want it to break if we start supporting pull-ups, let's just do it like that. Any CPUfreq yet? That's a lot of brokenness. Oh yeah, the sound stuff is quite broken on the bindings so far. Need to get Povik to fix that. Looks like the Bluetooth also needs some changes there. Yeah, there's a lot of no, I made that commit with that person on IRC. But yes, the conclusion was that we can use CPIO Hawk to fix that. So that's good. It should work on the M1 Max now. Yeah. Just tell me if any CPUfreq stuff is broken. I need to add the M2 stuff. Okay, that one's just really sad. Let me that one's just gonna complain forever. Looks like that did work though. Yeah, I think the CPUfreq is fine. We have so much stuff. Well, it's mostly that pmanager. Okay, let me add. I think we're fine on CPUfreq, but let me add that because that is very noisy. Did we ever settle on the right order for these things? We have 103 there. It was either release or like some kind of sort order, but then we put that one in the. Yeah. I don't know if we ever. Could be just alphabetical. I mean, I personally like this one where we have like the T8000 series first and the T6000 series second. And this one's special because the T6000 is just compatible with the T. It's a subset of that. So, nah. Let's just add it like that. I can always have that discussion later. Yeah. Was it 8 something? Is it P or I forgot? Code names. Or was that? Yeah, G. And then we had like C. These had like different names to them, like CD and an S. There, that's my argument for how I want the compatible sorted. People can argue with it all they want. But at least if they want to argue with it, they got my explanation first. We'll see what happens. Okay, I'll go with that. Anything else? Nope. Yeah, I think the checker was fine. So now just get this into the right branches. Does this actually work with trade with? Yeah. Oh, bindings. Well, that can go in the device tree because there's no special thing for that. It could go in MISC, but whatever. Oh, and I missed this one actually. Let's rename these in kind of the right place. Let's put that one before the 81121. Yeah, I'll go with that. Bits CPUfreq is where 130. And then we have the... Oh, I forgot to fix the move on here. which is fine. I can fix it as I rebase it on here. So let's just cherry pick it first. To that one. And then I can do a rebase on base. And in this one, let's do a break. Actually, just an edit. And then that has the rename, which I don't want. Sock, CPUfreq. Foo. And then we revert that. And then I can just, oh. Wait. Didn't I, oh, did the rebase break? Oh, because I'm rebasing, sorry. Yes, so, I need, nothing there. Actually, no. I just do it as another run, and so then the generalized one takes that as a fix-up, and then the bindings comes after that. And that actually has to go the other way around for it not to break. So that's a squash. And then the driver can switch. Okay, there we go. Just check the commits, but that should be fine. Yeah, that does that. That's just the binding with the rename. This is going to get squashed anyway, but... But for the purposes of testing on Asahi Dev for now, and on the Git stuff, this is fine. So, I think that's good, and I don't think I have anything else pending on my side, so let me go ahead and look at what we had on Asahi Dev. Is that on the 16th? Yes. So CPUfreq is done. What else I need to do? Yes, so we want the I2C thing, probably. That one is where? It's on Dropbox, apparently. Download. No. Is that actually going to let me download without? Okay. Yeah, thanks. So let's take that. That can just go in MISC. I don't think we have anything for I2C. Commit description is kind of lacking there. But I can live with that. It was mentioned. And yes, I need to take care of the scripts. Just open a tab on that. What else did we have? I don't think I have an actual batch from Povik yet. Do I? Um, did I have the... Yes, we have those in here. The Arch Linux package builds need to have that fixed. And there was the keyboard PWM thing. Am I missing anything? I think that was pretty much the right thing, except apparently we need to revert something. And I see we're getting jumped out. um, oh, this is on the audio branch. Is that not there yet? Oh, it looks like it's not in this branch. I think I was in a different. Yeah, that was in a different branch. So, um, let me just reply to some people on this. Okay, looks like we have some extra stuff here. The first and last two patches of this. So that one and those two. Fair. No. Oh. Okay, I'll go with that. I think we're good. Am I forgetting anything that needs to happen? Things that were broken here. The M1, yeah, so the M1 Ultra was broken for other reasons. Plus the CPUfreq. We fixed the hub thing. The codec thing, I think, was just missing the kconfig in the Arch Linux build, so that doesn't matter for the actual merge here on the tree. And then there's that PR with the keyboard backlight. Let me take a quick look at that. Joy says, forgetting to merge in the GPU. Oh my god, it works. Yeah. Actually, that's going to be an interesting story because, well, first of all, I need to rebase onto a newer kernel anyway, which I will try to do now. But also, when Rust goes into 6.1, like Lena has like from what I saw, a bunch of Rust for Linux branches merged in. So I think we're gonna have to wait until the Rust for Linux folks rebase those onto 6.1 with the Rust bits, and then I don't know how that's gonna work. We'll figure that out when she gets the driver at the point where she thinks it's supposed to be published. But yeah, I get the feeling that some of the merging is going to be interesting and kind of break my usual way of doing things. So. JetMed happy. Haven't had a chance to test it yet. Also, I might just merge the energy aware scheduling thing, because why not? I mean, even if it's not perfect yet. Where was that? Let's just do it, because why not? I mean, again, this is supposed to be a testing tree. You know, the things get upstreamed from here. It's not a big deal. Like we put it in Asahi Dev. If it works for people on all the devices, it gets pushed to users, and it's fine. You know, we do test it. It doesn't have to be finished. It just has to be reasonable, like a work in progress that is, you know, in a good enough state to be heading for upstreaming relatively soon is kind of the criteria here. So let me just grab. Oh, apparently you don't have that. Because really, it's all about the testing, right? I don't care if I break Asahi Dev, because I'm going to push the packages and we're going to test them, and if they work fine and the upgrades work fine on people's devices and nothing explodes and things work as intended, then it gets released to users. And if the testing says it works, it works. So let's take these. What? Why did that not copy? And I might rebase that. Let's just call that a fix-up. Oh yeah, we should remove the 42 out of 42 compatible. It's true. Arch from 64 boot DTS Apple. Yep. Let's just set this. Don't worry, I just did it anyway. I can just Povik is saying Jenna has a patch for it. Because I can do this. And magic will happen. Hopefully. Maybe not. T8103. Oh, it is only T8103. Then that's easy, yeah. And that's just the binaries and stuff, right? Yeah. And we can just fix that up. Sounds good. Joey asks if it's a different chip or not as compatible. Yeah, thing is, like, the compatibles are only supposed to list chips like that if they're actually 100% compatible with whatever comes after that. And it wasn't 100% compatible. It was just almost. But, like, that's not technically right. So if there is any difference that would cause the pre-existing driver not to work, which includes the check for the device ID, then yeah, you wouldn't want to actually do that. So that is that. Anything else? Let's see. I threw in the energy aware scheduling stuff because why not? Let me actually check that. Is there is this called EAS or shed or something? Is there a config for this? That might be fine. And also, while I'm here, if I'm going to be messing with sleep, I need to enable sleep. Okay, so it's automatic. Okay, so then we don't need to enable anything. So, I just realized, if we're going to be testing suspend, we want this. That's fine. And now it's going to take a full rebuild. Also, did I have a CPI enabled or something? I thought yeah, why is that enabled? That shouldn't be enabled. So that's going to take a full rebuild now, which means I'm going to do the merge. But let's figure out the keyboard thing while I'm here, if that matters. Constraint wait, hold on. Wait, now I'm lost. Where did that paste come from? The testing one, the one that chat met. Oh, okay, it's the channel restriction thing. Let's just go with it. Again, I don't care if I break these branches. If something doesn't work, we fix it. That's fine. That did work, other than the white space issue there, that one. I'll just fix that up real quick. There we go. What else? That's done. That's done. We did do those. Where is the PWM? This one. This needs review. Files changed 13. That many? Oh, the device trees. Okay, yeah, sure. Let's look at the driver. That's very simple. Control 0, on cycles 1C, off cycles 18. Try enable mode update trigger invert. Yeah, that looks nice. I might make a comment on this. Let me make sure I have the exact. CPUfreq. And that's because that one was based on something else, but we do have some examples. Yeah. That was also based on some other stuff. Let me find one that actually has the like these. Yeah. It's supposed to be GPL 2.0 only or GPL 2.0. Might still merge it though. I don't actually care about the license for R3, of course, because this is more about how it gets upstreamed. X module, OF device, one device. Yeah, that looks fine. Clock cycles, Apple, TRN chip, I've been basic. Clock rate, Apple, apply, container off. Enabled, on cycles, clock rate, times 2 to cycle divided by n per sec. I get the feeling there might be kernel like multiply divide APIs that avoid potential overflow here, but honestly at 64 bits I don't think it's going to matter. And it just writes the cycles, enable output, enable update. Otherwise it writes 0. Get state. Devm clock get enabled. Clock disable unprepare. What is the disable thing used for? That looks unused. Edit that comment. Mentioned the module license also needs to be changed. Actually, this is wrong. That's wrong. I think it's because I didn't realize that. And this is just not an actual module. RTKit helper, I think, has the right one. Oh, but I'm on the wrong branch for that now. Yeah. Let me get RTKit helper out. I should fix that. Yeah, dual GPL MIT is the correct thing. I should send a patch for that. Well, it doesn't really matter for Linux modules anyway, but... Yeah, I think the add action would have been for when the driver like unprobes or something? Because devm clock get enabled is supposed to do the disable automatically, right? So I imagine that was cleaned up to use devm, and then it's not supposed to. Oh, interesting. That's like missing entirely. I think it's just new, too new. Yeah, that was added really recently, so that explains that. Struct devm, yeah. Yeah, disable and prevent free devices unbound. Yeah, so that's fine. So yeah, that's dead code, but it's not going to break anything. That's devm. I think this is fine. This is all doing what I expect. Apple PWM, 5L2AM, okay. And then we have the maintainers. Yeah, that looks reasonable. Maintainers. I think that's in order. T6000. And those are disabled because they're not used unless they're used. Puts an OK. PWM LEDs, keyword backlight. That looks reasonable to me. I'm just going to merge it. I think we're good. Let me check the commits. Well, let's make sure that it actually compiles and everything. Where am I? There you go. Commits. Well, I need the branch. And I can just cherry pick these things, put them in the right place, I think. Do they have a signed off by? I think the CI would have complained if they don't. Oh, maybe it did complain. It doesn't. Yeah, okay. I mean, it's not like we have a rule that in our branch that has to be signed off. But yeah, we kind of need that. Do any of them have a sign off? Does this one have a sign off? I guess it doesn't. Yeah. Okay, I'll mention it in the review. Well, I guess this can wait for the next run then, just to make sure we get the sign off and no one's confused about that. I thought it's gonna be a problem though, but um, yeah, I think we're fine. Okay, we'll punt that for next time. Besides, I'm not testing on a laptop right now, so it doesn't make a difference. And I think that's it for Linux. So what I'm going to do is do the merge first, then do a rebase. Let me, well, first of all, make sure I don't have anything weird here. Oh, that needs to go in. I did put that in there, right? Yeah. So that should be fine. Let me just make sure. I didn't break anything. And this should just be the other changes. Yeah, those, that. Yeah, squirt C stuff, a jack, whatever. Yeah, that looks fine. Okay. So let's do let's see what Linus has in store right now, and we probably want to rebase until the on top of the release. Or the latest RC or whatever it was. Would be a release, yeah. That is slow. Oh, we have a 6.1 RC1 already. Okay, let's go with that then. So what the way I do that is base ref base, yeah, do that. And we make this 6.1 RC1. And then do Asahi rebase all, and let's see how many conflicts we get. So there's the device tree stuff. What changed there? Just an SIO dart happened. I think it's just an ordering issue. Parent has dart SIO. Did anything change here? I think it's the same. Yeah, it's the same. It's just the ordering. So that will go in CPUfreq hardware. Yeah, that's fine. Oh, wait, no, Dart SIO is... Wait, where did that... Oh, sorry, no, that's not what I want. It's just the ordering thing. So, because this expects to already have SIO. Wait, what happened to SIO then? Did that just move, or... I'm confused. Where did that come from? Uh, did that get removed? Oh no 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 no! That's because it was in my device tree updates, and then I didn't. Okay, yeah. Because those didn't actually get pushed in the end. I need to fix base for that. No, it just wasn't there at all. Because in base prev I have a merge of the 4 next stuff, which didn't actually get merged in the end. So now that RC1 is out, I can actually fix this 4 next. I think that's the only thing we have. So let me fix that first. So I can rebase this on that. On 6.1 RC1. It skips 1. Everything else works. Cool. No conflicts. That should be fine to push, actually. I'll wait for this, but yeah. So we just had a Asahi Talk DT, which is the same as for next. Then there was this, which is what? Is that already there? Hopefully. Oh yeah, that was just. Yeah, that's fine. That's already there. So we just need to merge that. I think that was a patch I put on the previous branch because it was upstreamed but not yet in the previous RC, and I needed that for the other patches to apply or something like that, and so I had it on top just randomly. So we don't need that anymore. So that should be merged now, which means I can actually rebase. And now I don't know if I'll get a conflict or not, but at least it should make sense. Okay, so that's just a skip. That is. Sorry, skip. I'm surprised that was clean. Of course, there's a conflict in mailbox. Was that already merged? Parent, his ad's flush. And, oh, okay, so we already have these. So I can just skip that. And this one. Yeah, I think this is fine. Yeah, we have those. Those are upstream, so that's good. And also, like Lena had some fixes to the mailbox and RTKit stuff that I think actually makes sense to just pull. Because they were actually bug fixes, from what I saw. Yeah, these are a bunch of them are not going to apply because this finally got merged, thankfully. Move.support its own file, yeah. Yeah, so we can skip that. Subpage protection, that one's just empty. Excellent. That one's also empty. That one's also empty. And now what? 64 stream IDs. Okay. Include. Okay, that's just pretty obvious. Anything else? Nope. And now what? This is T81, yeah. Head, parent. Oh, they just moved somewhere else? No. I think it's this one. Yeah, that got deleted. Which means that can just be dropped. As well as that. Continue the rebase, and then try again. Simple DRM. Backlight support. I guess that pipe got deleted. And then we have the pipe mode valid, whatever that is. Pipe. Yeah, I guess all that got dropped or something. Wait, but that's where all the backlight stuff is, though. Yes, the CPUfreq stuff is done. I'm just doing a big rebase now. Did this just move? What happened here? Wait, is that simply... No. Yeah, it might be moved to a helper. No. Might be this one. Yeah. Pipe disable becomes atomic. Okay, yeah, so this needs to be redone. So what I need to do is, first of all, just undo all this. Hardware settings, parent office, the backlight. Yeah, that's fine. And then in the this one, in atomic disable, we want to add that. No. And then we have atomic update and atomic disable. I guess atomic update would have to enable the backlight. I guess that's it. Unless the state needs a check for, like, whether it's actually enabled or not. Looks like it does have an atomic enable function. You might want to actually use that. Yeah, it should just be atomic enable and atomic disable. Yeah, okay, so we do actually need to add that. So that wouldn't be here. It would just be another one here. Atomic enable, and it's symmetric. Enable state, disable state, yeah, so we just do enter that and no mem set. I think that makes sense. Actually, do I need the DRM dev enter? Maybe. Oh, also enable. Will I ever do a collab with Asahi Linux? I don't know. Maybe one day. Doesn't she only do collabs with, like, actual VTubers? DRM dev enter. Yeah, I don't know if we need the enter or not, but I guess it can't hurt. This is a temporary patch anyway. This is not getting upstreamed. It's just getting replaced by DCP when that's ready. Okay. That's true. She did do a talk with Alyssa. Yeah. Audio. Let's see how badly audio. I think some things here got upstreamed. So yeah. Yeah. Okay, we can skip that one. That's in there already. That's empty. Another empty. Okay. Did this get upstreamed yet? Yeah, some of these got upstreamed. Let me just make sure that this is actually kosher. Oh, it just got put before that. One of items enum fmac, or one of these, or just fmac. Okay, it just got moved into the enum. Yeah. Yeah, that should be in there. What happened there? The reg info happened. Did board type go away? I got moved. Oh, that probably just got upstreamed first. That's fine. Let me just check that real quick. Oh yeah, that's already there. It's just order, so we can skip that. Yeah, obviously that one. Log. I think that's in there also. Yeah. I guess all these patches just got reordered. Yeah, that's in there. Yeah, it's in there. Or 378 is in there. And 377 also, I think. No? Okay, that's... Oh, because there's a Cypress thing that happened. Yeah, so we want to add that one there. That should be fine. Four three seven seven chip ID. Yep. Continue. Oh, come on. Get TC now. Okay. And 4387 is going to be the same deal. Or more, actually. Because, yeah, the ordering thing again. Yeah. Just a bunch of conflicts. Yeah, if Cypress goes at the end, then this has to go there. Need chip.c. Yeah. And then the PCIe. There's more than one there. Wait, where'd 4355 come from? That's like not sorted. Oh, that's the Cypress one, isn't it? Yeah, let's just put it there. And it is fine. Yeah, that's called 4355, but it's going at the end there. Then we need 4, 3, and 7. That's fine, I think. That looks reasonable. 87, 87C2, 87C2, C2. Yep, that's all right. Continue. And finally, another one. The other revision here. And then that needs to change to, we don't know what 4 is, so that would be fine like that. Diff. Yep. Continue that. Okay. And back to rebase all. Kconfig. Just. Head parent depends on head. Did the depend get dropped or something? Remove redundant depends on headlines. Yeah, of course. Yeah, default by hit apple. That's a typo. I'll just fix that while I'm here. Continue. Okay. I think we didn't do the revert. We didn't need that anymore. But there's a new Bluetooth for that. Sven mentioned that. Hold on. Let me go to the IRC log. Bluetooth v3, I think it was. Yeah, that. Let me find that in lore. Not there. It should be in Asahi. There, Bluetooth v3. That should do it. Apparently that came from Fastmail. Yeah. So let's actually are all the patches there? Yeah. So let's actually just call this a break. Oh, and it just yeah, that's not what I wanted, but sure. 100 Bluetooth. Yeah. So go to base and just get AM that. Yeah, we can skip the device tree stuff because that's already done, I think. Yeah. Okay. Did the device tree change in any way? Hopefully not. That all looks pretty much the same. Okay, and let's just do the rebase again. I don't think this one got upstreamed. No. But it's just the Rust stuff probably got in the middle of that, because I know there's... No, that's right. Oh, wait. What? Oh, the docs only. Okay, fine. Rust, yes. Hello, Rust. That should go after, because this is after the 4cc code stuff. Yep, that looks about right. Yeah, that was added. Okay. Another run. Yeah, I think we'll do the Wi-Fi some other day. I don't think I'm gonna jump into that after this. I think a rebase session is good enough. We'll do a smoke test on what head parent what did huh did did they just get sorted? I think it just got sorted. Someone decided to sort these. Yeah, sure. Um. And they are sorted by config line, I think. Yeah. Wait, this is wrong place. That's the right order, I think. DUI. Yeah, that looks fine. Wait, did I delete the... No. That's more like it. I think someone already fixed that one, if I remember correctly. Yeah. It's just they used from OF node instead of the... Oh, what's done so far? I guess this uses from firmware node instead of the yeah. Yeah, sure. Skip that. And it's gonna get redone anyway, so I don't really care if it's different. One more. Of course, there was another quirk added in the meantime. Okay, that's all of them. Let's do a merge. Okay. And let's see if it actually compiles. This is going to take a while because it's going to do a full build. Someone just pinged me on. I have 2 more if I can squeeze them in. Oh, sorry. Broadcom stock support, no. Why is that asking? They might config it wiped or something? I think at some point I must have done a config with other stuff. Well, that one's new. I don't think that's useful for us. Yeah, sure. Looks like there's some Armor 64 stuff got moved here, I guess. Okay. Let me just fix those crypto stuff. I'd probably get rid of some of those, but yeah, those. Don't care about SM3. But probably good to have the others. I don't know the configurations by heart. I just have an idea of how it goes. Okay, so Povik, get me 2 more things. Let me add those. It's audio. Reddit. Yeah, that. And the other one. Enable write cache. All right, this was to speed it up, right? Together with the I2C thing. Sure, we can do that. Let's do a merge. And it's building. It's gonna take a while. Okay, I'll be right back while that builds. And I think we're just gonna test it on the studio and just make sure everything works as intended and call it a day. Whoops, that didn't work. So is that because it only has to go in the plane? Oh, I guess it has to go on the CRTC or something like that. Yeah, okay, that I think it has to go here. Yeah, there's supposed to be atomic enable and atomic disable here. That's where they're supposed to go. And so then and I don't think we need those. Probably. Yeah, should be CRTC, and there's no inter stuff. That's failing on a bunch of places. I think simple DRM did work. Yeah, that's fine. So that did not work at all. Oh, this became remove. Yeah, okay. That should just be a fix-up then. Oh, simple DRM is... Oh, did I forget to remove that? Oh, yeah, I did. Hmm. That's just a new line change. Wait, what? Oh. What? Confusing myself. I think these are just new line changes, which I am going to apply, because why not, but mostly that one. Okay. And then some Broadcom stuff. And Mac Audio, num codecs. How do we get plain there? I keep messing up that fix up. Oh, it's not plain dev. It's CDC dev, sure. Read declaration of core with no linkage. $2276. That was a bad merge, I think. Yeah. Wait. Okay, that's just a bad, yeah. I need to get rid of that patch. Just do a revert for now to tell me that needs to go away. And what's the other stuff that's broken? Yeah, num codecs. What's up with that? Oh, sorry. Okay, you have a fix. I just saw that. Sorry. Oh, data links. Okay, sure. Mac audio. Nah. Okay, next, what else? In Broadcom, there was some stuff broken. Duplicate case value? Hmm. Hold on, what? Where? Which one? On 730 something? Yeah, what happened there? Oh, wait. Is that the same chip? Huh, oh, well, this could be... Oh, I sure hope that is actually... That looks reasonable, but is that really the chip rep we have? Okay, it's 12. So it is larger than that. So that matches. The problem is that, now the firmware has a different name because they named it that. Because of the stupid Cypress rename. Damn it! Now I need to fix our firmware extraction script. Well, this is one of the T2 Mac ones anyway, so nobody cares. Running Asahi, but... The question is it actually the same firmware? Because this is, like, we have the Apple ones. Is Cypress going to distribute this? Then we need to add the app. We do have the Apple name in the firmware, so that's fine. I should have upstreamed this earlier so they could deal with my way instead of me having to deal with their way. It's an automotive Wi-Fi chip. What? Are they actually distributing this firmware anywhere? Okay, I guess I just revert that change for now. So that we only need the OTP info. Everything else needs to be reverted here. Okay, let me do it like this. Revert. Okay, that doesn't work. I'll have two. Okay. Anything here? Yeah. Okay. Add those. Fix up for the fix up. Okay. Let's go on the Wi-Fi. And then don't do that. And then the 5.5 is an edit. So not that. Not that. Not that. But we do need that, except it has to be the new... that thing. So PCIe is for 355, apparently. No, wait, that gets added, but... Oh, so it is different. Well, crap. Is that like an OTP or something? Oh, there's more than one. Okay, that's why. So this has to be it. I do need the 4355. Wait, now 459 is 4415. That's... yeah, that one. And then the raw one is used where? So need that. Okay, so we do need the div ID table. Oh wait, there's a sub device. Broadcom 4. Oh, is this because they? Okay, you want to match the Apple ones? No, that's actually pretty old. Oh, no, but the device ID there is not 4355. It's a different one, so that's fine. I think we don't need that. That one bothers me though, the firmware thing, because if it's not actually the same, well, I guess we only match by this and by revision numbers, and it's only ever C1, and there's never going to be any more because these are old chips. I'll have to send an email about this. Um, uh, keep forgetting how this works. Origin bits, Wi-Fi. Yeah, I'll have to send an email about that. Continue. Let's just do it. Do a get rebase. Huh? Yeah, we can drop those. Okay. Asahi whip. I need to fix the backlight. Was that in MISC? I think. Yeah. Next up, the Mac audio. And Mac audio fix up. I don't know where that is. Let's do a break there and see what that changes. Oh, it's just there in Mac audio. Which, oh yeah, it's just there. Okay, so it's just the fix up for that. And merge everything again. And try building again. Oh, yeah, it builds. Okay. And let's just try running it. See how lucky we get. Lots of penguins. Oh, that looks broken. Runtime PM usage count underflow. Povik, that one's yours. Not sure if he's watching, but I'll send it. At least we have that. Card 0. We have 2 PCMs. Capture. Yep, that looks fine. Speaker is on. Primary. I thought the speaker was enabled on this one, or is it not? Looks like only the jack is. At least the Bluetooth looks like it works. Let's see. Wi-Fi works. Bluetooth hopefully works. Yep. At least it shows devices. I'll have to test on a laptop to check the backlight stuff, but yeah, it boots, it runs. I think the CPUfreq is fine, probably. Yeah, that looks good. Okay, I think I'm gonna call it a day. It boots. It smoke checks mostly. We need to figure out that runtime PM stuff. I'm not gonna dive into that now. So I'm just gonna push this as it is right now, and I'm gonna get some dinner because I'm getting pretty hungry, and then I might send an email about that Cypress thing because I don't like how they took over the 4355 chip ID with that Cypress like sub chip ID. And I would much rather they named firmware after the family, not after whatever Cypress names their chips. So I might complain about that later. But let me push that. Push. Yep, that looks good. Asahi whip. And yeah, I think we can fix the RPM stuff, which is a bit dodgy, test it on laptops and make packages for Asahi Dev for testing and see how it goes. Yeah, I'm glad we dropped some patches, some things got upstreamed. So yeah, next time probably the Wi-Fi thing again, the sleep mode. Yep, just looking at my to-do list, I fixed that stuff. Yep, we're back to Wi-Fi and then power management stuff, so we'll see. Okay. Well, that was a good stream. How long was it? 4 hours? Yeah, sounds about right. How many people do we have? 55, not bad for a rando stream. Okay, thanks for coming. When will the next time stream be? I don't know. I don't really plan my streams. It's more like when I'm working and I sit down and it's worth streaming. So just watch out on Twitter, I guess. Okay, thanks for coming. See you all next time. Bye.